Welcome to the lecture on sustainability and sustainable development. In this lecture, we will learn about the global environmental and social crisis that we face today. We will learn about sustainability as a concept and a vision to tackle those crises. We will learn about sustainable development as a process towards sustainability, and finally learn about the different components of sustainability and sustainable development that help us to bring the concept into practical application. We will start from a very big picture. Our planet has a limited capacity to supply us with the things that we need from it. Clean air, fresh water, productive ecosystems, and enjoyable ecosystems, and also safe ecosystems. And these different limits that our planet has can be quantified in terms of so-called planetary boundaries. These are major or salient parameters of the global biophysical or biogeochemical system that describe when a threshold is being crossed after which it becomes very risky. For example, that there is a high risk of so-called tipping points after which the whole Earth system will change to a completely different state with maybe very different weather patterns that are most likely not very helpful or supportive for the global population we have today, let alone other species. So we take these concepts of planetary boundaries to define a safe operating space for humanity. This is the space in which humanity has existed in over the last 10,000 years or so. The only state of the Earth system that we know we can exist for a long time. And we can measure how we interfere with these planetary boundaries and which we may already have transgressed. For example, on a global scale, we emit much more nitrogen and phosphorus than the world's ecosystem can deal with in a long run. And for climate change, we are on the very stable track of hitting the boundary as well and potentially triggering irreversible change in the Earth's climate system. We also have transgressed the boundary for biodiversity, meaning that human activity causes a huge species extinction which may destabilize Earth's ecosystems in the next decades and centuries. So this is the situation we are in. And this is then the definition space for sustainability, that we need to move away from such a development trajectory where we exceed human boundaries, but instead we need to redefine our economic activities in our society and also our energy material supply to come to a state where maybe or hopefully we can live in line with those boundaries in the future. And we can see that the contribution of different countries to global environmental challenges is very unevenly distributed. It's mostly the countries between 20th and 40th degree of latitude that contribute largely to environmental challenges, here symbolized by the so-called ecological footprint. That is a biocapacity indicator including impacts from built-up land, grazing land, and also greenhouse gas emission sequestration. So you see here many countries contribute vastly to the global exceedance of planetary boundaries, illustrated by this simple aggregate indicator. Globally, we also face major social challenges, and one of the biggest social challenges we have is income inequality. It's a situation where in a society very few people have most of the income and there's huge poverty across a large fraction of the population. This is known to cause social or societal instability. It's known to cause major political and thus also economic challenges for countries. So many countries do have an inequality problem, and not just to be an idealist, but actually for very practical reasons, this needs to be addressed by development policy to have a more peaceful, more stable, and also ultimately more prosperous society. We also have energy poverty, which is a phenomenon when too many people lack access to basic services for which we need energy, like clean water and sanitation, or comfortable building temperatures, or mobile or other forms of communication and transport. And you see the problem is especially widespread in sub-Saharan Africa and also in India and Indonesia. So energy poverty is one of the big sustainability challenges we have in the less developed regions of this planet. we can conceptualize the idea of sustainability by defining a safe and just space for humanity. So we need a place for ourselves where we can reach the major societal goals. So we can say there's decent supply of water, of food, we can articulate our political voice, there's peace and justice, and we have stable networks, for example. And there's many other societal outcomes and social targets that we would like to reach as a prosperous society. But we have to do that in line with the global limits that we've been given, the limits for climate interference, nitrogen pollution, ozone pollution, and so on. So there is somewhere this safe and just space for humanity. So it's safe to live, not only for the next 10 years, but maybe for the next 500 years or longer. And it's just. Just means it's not only a few people who get to live a good life, but it's almost everybody. So this is the vision, the safe and just space for humanity. So how can we get there? We can conceptualize the safe and just space by using the concept of sustainable development, where we say sustainable development is a process towards sustainability, which is a state of decent standard of living for everybody without compromising the needs of future generations. So it's a dual thing, right? It's not only about making everybody happy or well-fed today, but it's making everybody reach a decent standard of living, but at the same time thinking and taking into account the needs of the future generations. So it's a long-term vision to actually then live within the planetary boundaries and having a socially just outcome. Sustainability, as we know today, was framed in the late 80s to respond to the rising global challenges, both on the social and on the environmental side. But of course, sustainable thinking is much older. We have examples from Native Americans who have lived on their land for thousands of years, maintaining it in a very healthy state where generations of people could thrive. We have similar approaches in ancient China, where we had quite a highly developed society with also partly very high population density. And that gets very tricky in cultures that don't use fossil fuels. So they had to come up with concept to keep the land productive and keep also the population in a state where it doesn't grow too much and at the same time can live a just life for most people. We have the idea of sustainable forestry originating, for example, in Germany and Japan a few centuries back, where the idea of intergenerational thinking was made very explicit because trees take 2 or 3 generations to grow. So if you want to harvest trees to build large buildings or ships, you need to wait for maybe 100 years. And that means forestry is probably the sector where sustainability has to be applied and also has been applied in many countries in sustainable forest management for the last centuries already. Personally, as a researcher, I'm advocating for a 2-pillar model of sustainability. We have on the one side the societal outcomes, the social outcomes, that's the just space, and we have the safe space on the right side, the environmental outcomes. And in the middle we have our economy. This is the system that distributes the resources and allocates them to consumers and to production processes. And in my idea of sustainability, the economy is not a pillar of sustainability in its own, but it's more like something that has to be adjusted to the societal needs, the social outcomes, and the environmental boundaries that we're given. Sustainability has to be thought in a systems context. What does that mean? It means that we can't look at the problem too isolated. We can't only focus on electric mobility, because we also have to worry about electricity supply and worry about recycling and material supply. We have to worry about our cities. Can't they cope with all the new vehicles if everybody switches to electric? Or shouldn't we just redesign cities and maybe also switch to other modes of transport? We can't just focus on climate change mitigation, because then we will lose sight of all the different social outcomes that we also have to reach at the same time. There are many interlinkages, things that have to be thought together, and this thinking together is then operationalized in the systems context, where we know and understand that we have global supply chains that are interlinked, so we can't just produce one thing here without taking care of production and impacts elsewhere, and so on. So systems thinking is at the heart of sustainability understanding, especially in a scientific context. So what is now sustainability? It's the thinking of meeting everybody's needs without compromising the needs of the future. But is it a process? Is it a development? Is it a state of something, the property of something, or is it just a concept that floats around? And the answer is, it's a little bit of everything. It is definitely a state, right? So a system can be sustainable, for example, the Earth system in a hopefully future and today hypothetical states. And of course, sustainability is also a vision. Sustainability itself, it's not a process, it's more a state, right? But sustainable development is a process. So we can refine those concepts a little bit more. We can say, well, in the societal and policy discourse, sustainability is used as a concept and particularly as a vision. That's something, a state that we want to reach. In the scientific discourse, we would more say that sustainability is a systems property, so we can look at a system, for example a country or maybe global society, and can measure certain indicators and then decide whether these indicators are in a sustainable range or not. Then we can say, if yes, that the system is sustainable. And sustainable development is a process towards a state of sustainability. And a big question that I always raise and I want you to think about is whether or not a single country, a product or person can actually be sustainable if everybody is linked to the rest of the global system. So this is a question we will come back to in future lectures. A very important question about sustainable development is whether or not technology can substitute nature. So if nature goes bankrupt because we destroy it with our activities and energy consumption and other things, why can't we just use technology to fix it? For example, if our fields are not productive anymore because of a drought, we can do indoor farming. We can do multi-story, highly efficient, no pesticide, indoor farming and recycle nutrients and so on. What's the problem? Why can't we just substitute nature with our own capital and technology? If you say, yes, we can, we are in a notion of weak sustainability. So weak sustainability means that natural capital, like forests or other ecosystems, and manufactured capital are substitutable. So if we have not enough of one, we can use more of the other. So that means actually it's a much more hands-on and maybe easygoing notion about sustainability. It means eventually technology and capital, human ingenuity and work can fix the problem. A more careful notion is the notion of strong sustainability, where it's asserted that natural and artificial capital can only be substituted to a very limited extent. So that means we actually are dependent as a species on natural capital to thrive. There are certain things we cannot replace with technology, like maybe the atmosphere or the beauty of nature and so on. There is not really a clear consensus in science what is the right way of framing sustainability and who's right. What we can see today is that human activity in population has reached a scale that even if we could substitute nature with artificial environments, we could do this only for a very small fraction of the people living today. So for most people on this planet, this debate on weak or strong sustainability is irrelevant, because for them, they live in a state of strong sustainability. They are dependent on fields, on functioning atmosphere, water bodies, and so on. Only a small elite would be able to maybe live in a weak sustainable society where we can fix everything. But for the largest portion of people on this planet, it's not possible because we don't have the resources and the capital. So at the global level, we are dependent on the natural capital, and we see this as we see people suffering from floods, from droughts, and so on. Conceptually, we could visualize the weak and the strong sustainability as follows. We could say in weak sustainability, environment is something that can be embodied in the economy. The economy allocates resources, and if environment goes down in quality, we substitute with more artificial stuff. Strong sustainability, it's the other way around. Economy is embedded in the environment, so the environment dictates the framing condition under which then an economy can thrive or not. So the sustainability framing centers around these discourses or these concepts, but we want to become more specific. So in the last part of this lectures, I want to present certain components of sustainable development that are maybe a bit more down to the ground and can be also used in actual development discourses and strategies. So the first breakdown of sustainable development is a breakdown into the three aspects or components: efficiency, sufficiency, and consistency. So efficiency in the context of sustainable development means that we want to decouple the services provided from the energy and material consumption that is needed for their production operation. Efficiency is a term from physics that is defined as a ratio. Efficiency is the ratio of useful output over necessary input. And in sustainability, we want to have a lot of useful output, for example, a nicely heated or cooled building, or on the right side you can see transportation as a service, but we want to have as little input as possible, input of energy. So we could say that in a passive house, for example, that's only heated by the sunlight and by the heat of the people inside and the devices, we don't need additional heating and cooling energy. So we would call this passive house as extremely energy efficient. Or we can hope for, but it's not fully proven yet, that autonomous vehicle driving, shown on the right side, is very energy efficient because you can automate the acceleration and braking of vehicles, and you can eliminate the search for parking spots and so on. So this is efficiency in the context of sustainability. The next big thing in sustainability is sufficiency. Sufficiency is about questioning and potentially reducing energy and material demand by changing our consumption behavior, by changing our attitudes to what we need. And this is particularly relevant in very affluent societies where a lot of the consumption we do is just habitual consumption, or because we have the money we buy a lot of stuff, as you can see here with this cross-country skier. So this is also something that we have to address, because there's not much of a point if the whole industry is transformed to higher energy efficient products and services, but if we consume ever more of it, there's no sustainability in the system. And the last component of the three is consistency. And consistency here means that we have a certain eco-effectivity, so that there is no waste in the system, but that we can actually balance or reconcile the technical material cycles with the natural material cycles. So instead of polluting the environment with nitrogen and phosphorus emissions, we would try to recycle those nutrients back into our agricultural processes. Or instead of throwing away solar panels after use, we would try to recover the materials contained in them to produce the next generation of maybe more efficient solar cells. So all of this is embodied in a notion of consistency in the context of sustainable development, and this is also at the core of the circular economy vision, which is a vision of an economy with little material waste, so that we can actually decouple the technical material cycles from the natural material cycles. Then we have certain mechanisms in sustainable development, and one of the main mechanisms I already briefly talked about is the mechanism of decoupling. Decoupling means that one indicator continues to grow and the other one goes down. For example, in sustainable development, we want to decouple human well-being from resource consumption. We want more well-being in the future. People should maybe become happier or have their needs and wants satisfied, but at the same time we would like to reduce global carbon emissions, we would reduce energy consumption and material use. And there's two major forms of decoupling. The first one is when the energy use grows, but it grows slower than the beneficial outcome, which is well-being or mostly economic activity. In this case, we speak of relative decoupling. So when the GDP grows at 3% per year, but your energy consumption only grows at 1% per year. It still grows, but slower than GDP. This is what we call relative decoupling. And when energy consumption or emissions actually decline, then we talk about absolute decoupling. So absolute decoupling just means decrease. It says there on the slide, resources use declines over time. That means absolute decoupling. So we actually go down and the outcome still goes up. And relative decoupling is when we have different levels of growth. So when the resource or climate indicator still grows but slower than the social outcome. We can look at different countries and how their climate targets are structured, and we realized that some countries actually have set absolute reduction targets and other countries relative. If you, for example, look at Australia. Australia says by 2020 our national carbon emissions should be 5% lower than they were in 2000. And this is irrespective of economic growth, right? It doesn't mention any economic growth here. So this is a good example of an absolute decoupling target, right? We go down from a level that we had before. We still aim at more social benefits, higher growth, for example, but it's not a part of the target. The target means just we go down. That's absolute decoupling, absolute reduction. India, for example, says, well, we not want to reduce emissions on an absolute scale. That would be very unfair to us of India because their per capita emissions are really low at the moment. But we want to see that we can reduce our emissions per unit GDP. So GDP will continue to grow, but we reduce the rate at which the emissions grow by 20 to 25%. So per GDP, we have less growth of energy emissions, and this is a good example of relative decoupling. Another main mechanism of sustainable development is the discounting. Discounting is part of economic theory that suggests that we use or we assign a greater benefit to things or greater value to things that are closer to us in time than things that are more distant. Good example is the calculation of the net present value. Assuming you have a factory and you have a stable business model, maybe it's a solar plant and you have a nationally guaranteed feed-in tariff, so you know how much solar electricity you will be able to sell at which price in the next 10 years. But the future is less certain the more distant it is. So in your financial calculation, you would say, well, the money I will earn next year is safer than the money I'll earn in 10 years. Safer or more certain. Because God knows what happens in the next 8 years or so. In principle, I have it guaranteed, but we don't know what's going to happen. So what you will do is you will discount future revenue so that they say they have a smaller value in the present. The math is shown here, and this is an economic principle, but it very well describes the conflict we have in sustainable development. We want to meet our present needs, but we don't want to compromise the needs of the future generations. But how can we know what the future generations will need? Will they need all the things we have today, like iron ore or aluminium, or will they produce everything from timber or other organic chemicals? We don't know. So we somehow need to discount the future needs because we don't know exactly what they are. But at the same time, we can't discount them fully, only value the present, because we know that people in the future will need water and food and good living conditions. So we will have to leave something to them on this planet. And this balance between leaving a lot to future generations and not leaving much, this balance is then mathematically described by this discount rate or this discounting equation, and it can be applied also in the sustainable development debate. It actually helps you understand the conceptual relation between needs of the present and needs of the future generation. Here you see a good example of how you can discount present values into the future. So this would be the left side. We have a resource today, maybe a mine or an ecosystem, and we can calculate its present value and also its discounted value at future or to future people. We can also have the opposite, that's the mirrored graph on the right side, where we can have the future revenue that's discounted into the present and enters a financial calculation, for example. The last mechanisms I want to present you in this lecture is the environmental Kuznets curve. This is not so much an empirical finding, but more a hypothesis that tells you as people in a certain regions get richer, they first will deteriorate environmental quality because they will destroy parts of the environment to gather own materials and energy and own services. But as they get richer, they will have the money to pay for environmental protection. So people get richer and then the environmental quality increases again. And we see such relationships actually, for example, for local pollutions like pollution by sulfur dioxide or wastewater, which often is a problem in developing economies, but as countries have a certain welfare level, they tackle these problems. But unfortunately, we see no signs of the environmental Kuznets curve for resource use and greenhouse gas emissions. There, we still have a very strong correlation. More income means more emissions. So if there is such a curve, it would be at very unsustainable levels. So we can't count on these mechanisms in the face of the climate crisis here. I want to close this lecture with a few recommendations on concepts that I only briefly talked about in this lecture or not at all. First, there is a nice paper, a report about tipping points that you can read. Then we have some literature on resource depletion and critical materials that are underpinning the sustainable transition to renewable energies, for example. We have some concerns about a state shift in the Earth's biosphere. So this is the concept that we reach tipping points and then get to a new state of the entire biosphere. We have an old but very powerful principle of the spaceman economy, which is maybe more a circular economy, we would call it today, versus the cowboy economy of continuous growth. And we have, of course, the very important concept of the Anthropocene, an epoch that began when humans actually started having significant impacts on the Earth's biogeochemical cycles. And with this broad overview, I want to close this lecture and thank you for your attention.